Hello, bonsoir, Annie. Welcome to this Science North virtual star party and happy International Astronomy Day. My name is Aletha. I'm a staff scientist for SpaceCraft and the planetarium. And this is Lucy.
Hello, everyone.
Lucy is the science communicator for the planetarium, and we will be your host for this evening. We are streaming from Sudbury, Ontario, in Swakama. We are on the ancestral and traditional lands of the Atikamekw, Anishinaabeg, and Wanapitei First Nation. This land is in the Robertson-Huron Treaty area. And if you're joining us live right now, please share your location with us and your questions and comments throughout the presentation and night sky tour. Now to begin, I have a question for you. You can go ahead and answer in the comments. Can you think of a place that would be even better than Earth to do astronomy? I mean, Earth is pretty great, and it's true, telescopes make the best spaceships, and we do lots of our space exploration from Earth, but can you think of a place that it might be even nicer to do astronomy from? Imagine a place where there's no atmosphere. Think of how many stars you could see and how bright they would be. Imagine a place where it's never cloudy. How about where night lasts half a month? Where do you think I'm talking about? The moon. Yeah, the moon would be an amazing place to do astronomy from. And that is one of the things that we hope to do when we return to the moon. So right now, I'd like to share with you the global space community's plan to return to the moon. It's called the Artemis program. So between 1969 and 1972, the United States had the Apollo program. Artemis is the twin sister of Apollo and the goddess of the moon. So now she personifies our path back to the moon as the name of the program that plans to return men and the first woman and person of color to the moon in 2024. We are going back to the moon to learn. The moon is a natural stepping stone to Mars. And when we're there, we'll demonstrate new technologies, capabilities, and even business approaches that we need to explore further into the solar system. So on the surface, we are going to look for water, ice, and other natural resources. You can see in this image, the blue in the foreground represents water, ice. And of course, water is so important for life. And having water already on the moon is going to make it much easier for humans to live and work there. We're hoping that this program will create new jobs, will help improve life on Earth through spin-off technologies, and it will also help to broaden our industries and our international partnerships as we explore the moon together as a world, as a global society and a global space community. We also hope that these missions that will be shared back to Earth will really inspire youth to pursue careers in science, technology, engineering, and math. And of course, the moon will be an amazing platform to study the universe from. So we do have some science objectives on the surface of the moon. We want to be able to do field geology with mobility. So being able to have rovers that allow astronauts to cover a wide area. We want to collect samples, return them to Earth for analysis, like we're doing with Perseverance from Mars. And we want to develop the ability to access regions with very cold temperatures. So the landing site that is planned in 2024 is going to be the south pole of the moon. And one of the candidate sites is Shackleton Crater. So that's why we see a crater in this image there. And of course, we'll also be installing surface instrumentation, so scientific instruments. So this is an image of Shackleton Crater. It's a visualization. The near Earth side, the Earth-facing side of the moon is to the right. And on the left, we see a false color overlay showing elevation. So blue is low and red is higher. So this crater is 21 kilometers wide and 4 kilometers deep. So it's about 3 times deeper and wider than the Grand Canyon. Now, the really cool thing about it is the way light falls on the crater. So this is a movie of a visualization of the moon going through a full month, so a full rotation around the Earth. And watch how the light hits the rim of the crater, but it never reaches the floor of the crater. And the rim of that crater is often lit. So this makes it a really good site because water ice can't exist on the moon when in a place where sunlight's going to hit it. So you need a place in permanent shadow to find water ice. And that is up on the floor of this crater. So astronauts would have access to water. And on the rim of the crater, we can set up solar panels and always have electricity from solar panels, so we have light to work by. So that's the location. Those are the reasons for it. And now, what about the mission elements, the components? So we're going to need a whole new spacesuit. And it's not even really a spacesuit. It's called an Exploration Extravehicular Mobility Unit. So an XEMU. So that's what we're seeing images of here. XEMUs allow astronauts to bend their knees, to use their arms, and they can actually plug these suits into the lander to recharge between uses. And they've got tools, and they're just a full unit that allows them to live outside of the lander. So these suits, I've seen cool videos of people trying them out, working in them, and we will be testing them on the International Space Station in 2023. We're also going to need a rocket. So that's going to be the Space Launch System. This is a pretty big rocket, not quite as big as Saturn V, but the Block 1 Space Launch System is 322 feet, and the Block 2 is 364 feet. So about 17 feet taller than the Statue of Liberty for Block 1 there. And you can see down here, there's like a little human and a giraffe. So just to give you an idea of the scale. Here is the SLS at the B2 test stand. And here it is at the Orion Kennedy Space Center. It's atop a transporter and it's in its shipping container here. So this is the crew module. This is where people will be living and working, going to the moon and returning, but also Orion, it's been designed to take people to Mars. So it's big enough to make the trip to Mars. It still looks pretty tight, but it has been designed to accommodate 99% of the human population, adult human population, which is a larger range than any capsule that we've created before. So it can accommodate an astronaut that is 4 foot 10 inches, so a fairly shorter astronaut at 4 foot 10 inches, or somebody 6 foot 5 inches tall. So this just expanded the possibility for people being astronauts, which is pretty cool. And it does actually have 30% more room than the Apollo capsule did. So the Kennedy Space Center is actually being transformed into a multi-use spaceport that will be capable of sending humans on these missions into deep space, into the moon, and to the moon and onto Mars. Here is the launcher. It actually rolls and it will be returning at sea. So the Orion capsule will be landing in the ocean. Another important piece of this mission is the human landing system. So this is sort of the last piece that actually carries humans down to the surface of the moon in 2024. All right, so it's broken down into 3 parts, Artemis 1, 2, and 3. So Artemis 1 is going to be an uncrewed test flight of the Orion spacecraft with the Space Launch System in 2021. Artemis 2 is going to be the first ever crewed test flight of the Orion spacecraft, and it's going to be launched with the SLS rocket in 2023. So during this mission, the astronauts are going to fly deeper into space than we've ever gone before, like out past the moon. And the mission length is flexible to accommodate the science goals, but it may last up to 21 days, this flight test. And they'll be traveling over 400,000 kilometers from Earth. Finally, Artemis 3 in 2024 will be the mission that lands the first woman, the next man, and a person of color on the moon. So Artemis 3 will be the culmination of really rigorous testing. It will be a crew of 4 astronauts. And yes, it's going to be very exciting. I'm very excited about it. Now, another part of the Artemis program is creating the Gateway. So this is a small space station in orbit around the moon, and it's really building on the legacy of international collaboration between countries. So 8 countries have already signed the Artemis Accord, Canada being one of them. So that's pretty exciting, and more hopefully will join as well. So this is something we're going to be building together, and it's going to be a science laboratory and a test bed for new technologies and a hub for operations and exploration missions to the surface of the moon. So Canada's contribution to the Artemis program is a robot arm with artificial intelligence. It's going to be known as Canadarm3, and it will be on the Gateway. Canada is also contributing a program of innovative science and technology designs for the moon. So there are going to be new career opportunities, interesting possibilities with that. So Canadarm3 looks a lot like Canadarm2, which is on the International Space Station right now. And you may have seen it also on our $5 bill along with Dexter. So Canada actually has a really good reputation for space robotics, and that's pretty exciting. And Canadarm has a really cool role to play because Gateway is not going to be continuously inhabited, not like the International Space Station, which currently is continuously inhabited. Gateway is going to go through long stretches of time where there are no humans on board. And this artificial intelligence, this Canadarm3, is actually going to be maintaining the station and even running science experiments while the humans are away. So Gateway is going to be occupied at least once a year, and it will support missions down to the surface of the moon lasting about 6.5 days. In return for contributing Canadarm3 to the Lunar Gateway, Canada is receiving a whole range of opportunities for lunar science, technology demonstrations, and commercial activities, as well as 2 astronaut flights to the moon. So a Canadian Space Agency astronaut will be part of Artemis 2. So being nearly 400,000 kilometers away from our planet, the moon represents a crucial step in humanity's quest to travel onwards to Mars. And in the 2030s, the plan is for Orion to take astronauts from the moon to Mars. This is our next destination in the solar system. Now, landing humans on Mars may be our next mission after the sample return mission, which has been planned to return samples that Perseverance is currently on Mars collecting right now. So I love this evolution of a Martian. And you can see the return sample mission here. So this is Sojourner, Spirit and Opportunity, Curiosity, Perseverance, the sample return mission, and a human. This picture was actually taken by Curiosity. It's of Earth in the Mars night sky. This was taken January 31st, 2014, about 80 minutes after local sunset. And it just invite you to imagine actually looking back at Earth from another planet, maybe looking at Earth through a telescope. Oh, hello, Buster. Okay, thank you very much for that. I would like to just acknowledge that that presentation was an adaptation from a presentation shared with me by Patricia Moore, who is on the Artemis communications team for NASA. And she encouraged me to share these images with you. Okay, so if any questions came up, we could answer a couple questions now before we dive into our night sky tour with Lucy. Okay, so we've got one. Why did they choose a crater? So the reason they chose a crater was because of how the light is hitting it, right? They chose the South Pole so that they would have an opportunity to always be able to work with energy from solar panels because the night does last half a month. So that's a strategic location. But the reason not to just be in a spot where it's always light is because you want to have a big area that is in perpetual shadow. So that big crater creates that crater floor never sees light, and so it can preserve water ice, which is important for exploration. And the particular crater, the Shackleton crater, I think part of it is its size, location, and I know there are a couple other sites that they are still looking at, because it's going to depend on exactly when they're launching. They don't have their launch dates set yet. I had a comment asking if I've ever seen For All Mankind and their moon base. You know what? I haven't actually seen that yet. Oh, hi, Donna. Thanks. Donna says, wow, go Canada. And go US too, they're leading it. So the Artemis astronauts, when they're on the moon, the plan now is for missions to be about 6.5 days long. 6.5 days long. I guess that's not an about, that's pretty exact. So not super long missions actually on the surface, but the gateway, like their little space station, is sort of like the office. It's like a spot they can go back to and have a little bit more room to work and do things. The human lander, that module, is fairly tight quarters. All right. Well, thank you so much for those questions. And I'm going to turn it over to Lucy now for our tour of tonight's night sky.
All right, hello everyone. We're going to be using Stellarium Web. So if you head over to stellarium-web.org, the link is in this description. You'll be able to use this program. It's a browser-based program. And there's, in fact, a few different variations of Stellarium. There's a free downloadable version too. And there's even a phone or iPad app you can use. So it's a very useful program to help you find constellations, stars, um, planets. So we are, in fact, looking at the night sky here at past 10 o'clock when it's nice and dark. So the sun has been setting much later than it has been the last little bit. So it's going to just keep on setting later and later up until the summer solstice. So we'll have to go outside later and later to be able to see a nice dark night sky. And we're looking towards the west. Now, today is the International Astronomy Day, May 15th. It's a day that we also do like to take a look at the moon. We just talked a little bit about the moon and the next moon mission. Now, we can see the moon tonight as long as there's no clouds in the way where you're at. Hopefully, you have a nice clear sky. You'll be able to see the moon in right next to this kind of like reddish dot. It's right next to Mars. So the moon is a crescent moon tonight, just a little sliver and not too far from Mars. It'll be really beautiful to see looking towards the west. And Mars and the moon happens to be in a constellation. I always like to start with some of the brighter stars, makes it easier to find those constellations, and then star hop from there. But sometimes if you know, for example, that a specific planet is in a certain constellation, you can try to look for some bright stars around there. So Mars and the moon happens to be tonight in a constellation that has these two bright stars and a few other stars down here to make the rest of the constellation. So if we link the stars together, we happen to have a Gemini, the twins, one of the zodiac signs. It's you need a bit of imagination to see the whole constellation. A lot of these constellations need a lot of imagination, but their stars, the two bright stars, make up their head. One star is called Castor, the other one's Pollux. It happens to also be the names of the two twins. And one thing that's really neat is that the planets, we do orbit around the sun. The further away from the sun the planet is, the slower it moves. So, for example, if we're looking at Mars and then you see Mars tomorrow night, it doesn't really look like it's moved quite a bit. But if you keep going outside night after night, you'll see a difference. So, compared to last week when we were looking at Mars, Mars was a slightly different location. We can, in fact, with this program, go back in time. So, let's go back to a different day. We'll just let my program kind of load. There we go. So if you go back, for example, last week, Mars was on the other side of Gemini, just near his leg. But today, it's right in the middle. So it really it'll move across the night sky, and it moves along this imaginary line known as the ecliptic. The ecliptic is the line, the imaginary line, because we can't see a line in the night sky, but it's the path where the sun's traveling through. So we're able to tell that as the earth goes around the sun goes in front of these constellations that we call the zodiac signs, and the planets and the moon happens to more or less follow that line also. They'll be off maybe by a few degrees, but it'll follow that imaginary line. So eventually Mars will move into the constellation of Cancer and eventually through Leo until it goes around the sun and makes its whole orbit around the sun. Now, there are a few other neat constellations that we can take a look at. I'll take away the line so we can see what it looks like without them. So, not too far from Gemini, we're now looking further towards the south, towards the southwest here. High up, there's this bright grouping of stars that makes this kind of like reverse question mark. And then there's this kind of triangle over here that makes up, well, the tail, and over here would be the head of Leo the Lion. It's a very fun constellation. It's known as a spring constellation because we get to see Leo in the night sky after the sun sets throughout the whole spring season. I skipped over Cancer the crab that happens to be in between them because, well, Cancer doesn't have a lot of bright stars. It happens to be my zodiac sign, but it's a hard one to find. So if you can find Leo and if you can find Gemini, you'll know that Cancer the crab happens to be in between the two. Now, let's see if there are any other questions. Uh, Olathe, are you around?
Yeah, here, hi. So we have a question about Mars. Will Mars be visible all summer?
Ooh, I believe. And you know what? I haven't actually looked it up. Have you looked up to see
I
how
haven't
long?
looked it up. Let's just fast forward time for a second and see. I feel like it
Exactly.
is going to be around.
Yeah, I think it's gonna be around for a little bit. So this is June.
And here
Um,
too, you can see how you can set the date. So if you want to see what the night sky looked like the day you were born, you could actually set this to your birthday, have some
you
fun
can
with
go
it.
very far back in time. You can go forward in time. It's pretty remarkable what you can do here.
Yeah, it's very cool. And another question we had while we're checking out Mars's status for the summer, one of the questions was, when is the Artemis program starting? And it has started. It was announced in 2019, giving them 5 years to get to the moon. The Apollo missions got men on the moon within 8 years of the announcement, so a little more ambitious there. And we've already been doing the tests on the SLS, so the Space Launch System. So it's had a couple of hot tests, and it will be launched this year, 2021. And then yeah, it's rolling. So now it's happening now. It started in 2019.
Very neat. So sadly, Mars will only be visible after the sun sets pretty much all of June, but once we get into July, it's very low in the sky and we won't really be able to see it very well.
We also had a comment that it sounds like it's going to be a good night for astrophotography. One of the links we'll drop here and is in the description is to Clear Dark Sky. And that's a really great resource and tool for seeing, what your cloud cover is going to be, but also your transparency and your seeing, so how much moisture and interference is going to be in the atmosphere. So you can check that out. And it does look like we are going to have clear skies here in Sudbury tonight, so we're excited for that. Perfect for International Astronomy Day.
Yes.
And I think the seeing and transparency will be average.
Yes. So hopefully we'll be able to see some nice things. All right. Any other questions?
That's it for now.
Perfect. Wonderful. Thank you, Aletha.
Yeah, no problem. And yeah, if there's anything you guys want to see or anything you're curious about, we are always happy to answer questions. We love that part of this.
Yes, it is so much fun.
Oh, we just got a hello from the Philippines.
Ooh,
Hey,
hello.
hi. Wow, glad to have you here.
So if I haven't mentioned it yet, this is the night sky we get to see in the northern hemisphere around where Sudbury is near the 46th north latitude. So if you're around there, this will be the night sky you'll get to see. If you're further north or further south, the stars will be a bit different. They'll be at a different kind of spot in the sky. And if you're further south, you'll get to see some stars and constellations that we don't get to see here in the northern hemisphere. All right, so I'm gonna head over and pan towards the north to take a look at some constellations in this direction. It's one that it's a lot of fun to take a look at because here in the northern hemisphere we can see the stars kind of like in this area in this kind of like area here a year round. So it might be at a different spot. For example, this bright cluster of stars might be further down here in 6 months, but we'll still be able to see it in the night sky. And taking a look at that bright cluster of stars, you might recognize it. We've got this kind of like handle and pot area here. It looks kind of like a nice scoop, a little spoon. So it's actually a nice big spoon. It's the Big Dipper. The Big Dipper, though, is an asterism. It's a simple formation of stars that's part of a constellation. And to make the rest of the constellation, we've got these stars here for a head, some stars for the front paws and back paws. So this one does need quite a bit of imagination. It happens to be Ursa Major, the big bear. Some of you might have recognized this. Big bear that has a really big tail. But from here, we can do a bit of star hopping. So taking the two stars right at the edge of the pod of the Big Dipper, we'll follow that imaginary line outwards to find Polaris. Polaris is the North Star, the star that's nearly right above the North Pole. So as the Earth spins on itself, it's a star that doesn't move no matter what time of night it is. If we can find the North Pole, we know for sure we're facing north. So since this happens to be above the North Pole, we know that we are facing north. And Polaris happens to be part of its own grouping of stars, which I don't always have a lot of. It's not very easy, I should say, to find all of this constellation because these stars over here aren't that bright, especially if you're near any towns or cities. There's a lot of light pollution. These two stars aren't too bad, though. A trick I use is I always see it as if it's kind of curving towards the Big Dipper. Or, well, since this one here happens to be the Little Dipper, you can kind of imagine like it's pouring something into the Big Dipper or vice versa. But it happens to be part of, just like the Big Dipper was part of the Big Bear, this is Ursa Minor, the little bear, another bear with a really big tail. Now, from here, one of my favorite things to kind of star hop from, there's a few actually. This Big Dipper is a nice one to star hop from. Here we go. We're gonna Oops.
While we're shifting over, Lucy, I just wanted to say hello to Michael Agua from SSM near Lake Superior, who's joined us. And Dan Scott says that his son wants to know what we think of a hook and tether for space travel. And also they're wondering about what kind of commercial activities are being considered for the moon. So a hook and tether for space travel it's basically a sky hook. So it's a rotating satellite with a very long tether and attached to the Earth, and a shorter tether with a counterweight. So it's kind of like holding it, kind of centrifugal force style, holding it out in space as the Earth orbits. And then you can use this to kind of fling spacecraft into space and give them some momentum. I think it's a pretty cool idea. I'm also a fan of a space elevator, which it's a kind of a similar concept where it's a big long tether attached to Earth, and then we can use that as basically an elevator to space, and it would be a lot more energy efficient. So definitely think those are really interesting ideas. It's very cool that you're asking about them. In terms of the commercial enterprises on the moon, I haven't looked into that too deeply, but I did hear a talk by astronaut Harrison Schmitt, he was the only geologist who ever went to the moon. He went on the Apollo 17 mission, the final mission to the moon. And he was saying during that talk that he thought one of the things we would be doing on the moon is mining. And one of the things we would be mining for is helium-3 or tritium, which is apparently in short supply on Earth, but is a good candidate for nuclear fusion. So on Earth, we get some energy, some power from nuclear fission, breaking atoms apart. Nuclear fusion is putting them together. That's how we're getting our energy from the sun. The sun is a big nuclear fusion reactor. And that might be a safer way to get energy on Earth with less waste. So we might be taking helium-3 from the moon and bringing it to Earth and using it for power. But I'm sure there are lots of other ideas out there. And actually, if you want to learn more about the Artemis program, we'll drop a link in the chat to the Canadian Space Agency's Artemis page. And you can learn more about it there, and of course on the NASA website as well. Right.
Perfect.
Thanks,
Thank you
Lucy.
so much. All right. So in between the Big Bear, Ursa Major, and Ursa Minor, there's a tail here, and kind of like a snaking body of Draco the Dragon. So if we take the constellation art and lines away, you can kind of make it out here. There's some bright-ish stars kind of go around the little bear curves back, and these 4 stars makes the head of Draco the Dragon. And its head happens to be really close to this bright star called Vega. Vega is part of a constellation that well, there's these 3 bright stars from 3 separate constellations that make up an asterism known as the Summer Triangle. We get to see the Summer Triangle naturally during the summertime, during the whole summer season. So we're not quite summer yet. We don't get to see all 3 constellations at this point just after sunset. To see the rest of it, we do need to wait a little later at night. So we've got Vega here. That's part of this constellation that I always thought it looked a bit like a fish. We've got a tail here and a body here, but in fact, it's supposed to be lyra. A lyre is a music instrument.
I
Now
think
we
it's
have
kind of like a tie. What do
it
you guys
does
think it
also look like a
looks like?
tie.
Yeah.
Exactly. So you can have a little bit of fun with the constellations, that's for sure.
We've got a
Um,
satellite passing over.
yeah, so we have quite a few going by. We've got a Starlink going by
Oh,
right
that's one of
there.
the Starlinks. So those are the ones, sometimes you see them, this one looks like it's on its own. Sometimes you see them as a big, long string of satellites. So if you've been looking at the night sky and wondered, like, what is that? Because you saw a string of lights, that would be the Starlink satellites for satellite internet, which is great for remote communities in Canada.
Ooh, yes. Yes, if it's a nice constant light that's slowly moving across the sky, that is a satellite. If it's a nice flash, big quick flash, that is a meteor. And well, if it's moving faster and flashing, that's probably either a plane or a helicopter. So we have this other constellation here that's just starting to peek over the horizon towards the northeast. We've got these stars here, some more over here, down here, and over on this side. So we've got kind of like this long neck, two big wings, and tail. So it happens to be Cygnus, which is a swan. It's the second constellation that's part of the Summer Triangle. The third one is down here. So the three bright stars does make a nice big triangle in the sky. Here, the triangle won't look super big. We're looking at it on the computer. The sky is much bigger, so it'll look really big outside. Now, we also happen to have here, as we can see, Hercules, not too far from Draco's head. Hercules here, well, just by linking the stars together, it doesn't look like a whole lot. But we happen to have our Greek hero up in the sky. And I also really like to find this kind of like U shape. So it looks like a bowl, and you can really see that kind of like U shape or horseshoe shape. This is Corna Borealis, which is a crown, the northern crown.
I like too how one of the stars is near the center is quite bright, like kind of like the
Yes.
jewel in the crown. I'd also like
Yes.
to give a shout out to Amy Lance. She's joining us from Pembroke, Ontario, and she's looking forward to doing some stargazing with her children this evening. So that
That
is awesome.
that is so wonderful. Another way we can do a bit of star hopping using the Big Bear or the Big Dipper is using the handle of the Dipper or the tail of the bear. And if we take away the lines and arch, we can see just the stars here, how you'd see it outside. You can make an arc with it, with the handle, the tail, down to Arcturus. Good trick to use, arc to Arcturus. It happens to be part of Bootes. He's a herdsman, and he happens to be right next to the Northern Crown.
We also call him the ice cream cone.
That too, yes. Yes. I also thought he looked a bit like a kite, kind of like a
Yeah,
kite, and
yeah,
then
I
like
can see that.
strings or streamers coming from it. Yeah.
You know, and sometimes even if you're not in a really dark place, it can be great to get out and stargaze because you see these really bright stars, and it can actually be easier to find these constellations. Um,
Yes.
yeah, just in a city park in a shadow, you can actually see a lot of this.
Yeah. If you're somewhere where there's absolutely no light pollution and it's really dark, I've seen that once where it was so beautiful. I was in the middle of nowhere in the Rocky Mountains. And it was kind of hard to find the constellations because there's just so much stars everywhere. It's hard to tell which one's the brighter ones compared to the fainter ones.
Mm-hmm.
Now, underneath Ursa Major, the Big Bear, we do have Leo the Lion down here. And we also have Leo Minor. It's a little lion, but it also doesn't really have any bright stars. But if you can find Leo the Lion, the Big Dipper will be right above it. Now we're facing towards the south. Another little bit of star hopping we can do. After arcing to Arcturus and Bootes, we can spike to Spica, which happens to be the brightest star in Virgo the Maiden, and another zodiac sign. And she happens to be next to Leo the Lion. So she's right on the left of Leo, towards the east. And then after Virgo, we do have Libra, the scales. And once it gets a bit later, so probably past midnight, we'll get to start seeing Scorpius. Here we go. So this is at around 11, almost 11:40. We can start seeing Scorpius starting to rise up in the sky. And it has a really nice bright star in the center. Aries, it's a reddish star, or red supergiant. It has this reddish tint to it, but because of that reddish tint and the fact it's in a zodiac sign, and with planets traveling along the zodiac signs, a lot of people would mistake it for Mars. So way back in the day, they called it Aries. Aries is the Greek god of war. Mars is the Roman god of war. So they're synonymous. Aries means pretty much not Mars, just to remind us that this star is not Mars. It's wonderful.
Now, some of you might be wondering why it looks kind of cloudy and bright over there. around
right over here.
Scorpius. Yeah.
Yes.
Does
So we
anyone want to leave in the comments what they think that is? What that's going? What's that all about? What is that?
what is this band up in the sky? The little cloudiness. So while we wait for the potential answers, if
Ooh,
anyone would
I have
like.
something to share too. Just while we wait for the answer. So I didn't know until I started working at Science North and I got to start playing around in the planetarium. I didn't realize that the planet has a little bit of wobble in its sort of the axis that it spins on kind of wobbles a bit, and so your sign, like if you're a Libra or Scorpio or whatever, that's determined by which constellation would have been behind the sun when you were born. So which constellation the sun would have sort of been blocking out on the day you were born. And after working at the planetarium, I learned that because of the little wobble, the constellation that was behind the sun when I was born wasn't Scorpio, like I had been told my whole life, because October 25th means you're Scorpio. It's actually Libra. And you know what? I was kind of relieved because Libras are all about balance. And I was like, oh, I can be a Libra now. Oh, and Sarah Lavalley has the answer. Is it the Milky Way? Yes, it is. Yeah,
It
the
is the
Milky
Milky
Way.
Way.
So that is our galaxy. We're seeing our galaxy. And our galaxy is kind of disc-shaped. Imagine it like a big plate. And if you're in it and you're looking through the plate, you're seeing lots of stars, right? But if you're looking up or down, you don't see as many stars. So that is the disk of our galaxy, and it's really thick and bright there right on the horizon because that is the galactic center, home of the supermassive black hole that is holding our galaxy together.
Yeah, looking in this direction, we're looking toward the center of our galaxy, which
Yes.
is so neat.
Well, Lucy, thank you so much for that night sky tour. I think you gave lots of things for people to look for.
Yes.
And you know, you might have seen those constellations with us before, but we learn through repetition. Make sure to actually get out and try and see if you can find them in the night sky. You can download Stellarium as a free app on your phone. There are also lots of other apps you can use and just actually hold them up to the sky. Of course, there are also printable maps online. So get out there, connect with the sky, and enjoy some clear skies, at least here in Sudbury. And do remember, if you enjoyed this content, give us a like, give us a follow, and you'll get more from us. We were hoping to be gathering in person next week. The lockdown's been extended, so we're not going to do that. We are going to give ourselves a week off, but we will be back here, same time, same place, Saturday, May 29th, with another virtual star party for you. So thank you, merci, miigwech, and keep looking up.
Bye, everyone. Till next time.